Hello, my name is Giovanni Arredondo, and this will be our discrete structures presentation video. I will be going over the first part, and that first part will be why is discrete structures important, and that is because that it forms the mathematical foundation of computer science. It enables us to model, analyze, and solve real-world problems in areas such as algorithms, data structures, networks, or even cryptography, and more essentially powering the logic behind modern technology. Now, now you might be asking, well, what's a good usage of this discrete structures, you might ask? Well, one of the main ones that we use commonly every day is GPS. So the GPS or the navigation system uses graph theory, which is a key part of discrete structures. Since cities and roads are modeled after graphs, there are intersections, there are nodes, and roads are edges. Algorithms that are based on logic and computation are used to find the shortest and fastest route between two places. That's discrete structures in action, helping millions of us and everyone else around the world navigate the world every day.
Hello. For our discrete structure example, we chose to show a recursive function. Keeping it simple, we used an EMI formula populated with user inputs. After following the prompts to input the principal, APR, and frequency, these values are moved to the single payment calc function. Variable C is initialized within this function to keep track of the interest. D, which was previously our frequency variable, is subtracted by 1 at the start of every function as a way to keep track of iterations and prevent it from looping infinitely. When D equals 0, we return the final output. Otherwise, B, which was originally our principal variable, has C added to it, and then we call the payment calculator again, but now with the new upgraded value for B and the downgraded value for D, which again is principal plus interest and the frequency. And is finished looping, we output the total principal plus interest and the little print statement. Thank you.
What is discrete structures? Now, discrete structures, right, as opposed to like continuous. Something's continuous, it just, there's no defined edge. Discrete means there's like a certain, like a concrete way of doing things. So, discrete, you can think of a structure that can be repeated over and over, and it's going to give you the same result. Okay, so now, discrete structures, it's a little about it's a little bit about everything. So, for example, set theory, that's its own research area in math. So we talked a little bit about set theory. We talked a little bit about logic. Now, what do we mean by logic, right? Logic, true or false statements. Those are like the key things. But with those statements, you can do, like you can think about bits, binary, zeros and ones, zero false, one true. Um, how a computer works, everything. You have statements. Every wire is gonna do like a certain thing. But yeah, that's pretty much it. But yeah, proofs. There's a way of saying something's right or something's wrong. There's a way you can argue for it. What else? Functions, Boolean algebra. That's algebra when relating to true and false. Oh, graphs, which was a little bit about towards the end that we touched on, right? But graphs, that's really big in programming, right? Which is also discrete structures, right? Graphs and trees. So it's like doing all these algorithms. Like for example, on your GPS, your every street corner is a junction between two different streets. Maybe it's more, but usually it's like two different streets that are crossing, and then you put one address and then you put the other address, and then the GPS is gonna find within that tree is gonna find like the shortest path. So yeah, that's kind of summing things up right there.
And that would conclude our group project be on disrupt structures, applications. To sum it all up, discrete structures is the study of objects that can be represented infinitely or countably. It's applied in computer applications, representations, and in everyday life. It all mostly deals with logic, representation, relations, computations, and graph theory. So thank you for listening to our speech and have a great day.